Hello there, it's Mr. Baird. I'm going to work with you guys through congruent figures. Um, so we know congruent from like congruent segments, congruent angles. Well, now we're going to put it all together and talk about congruent shapes. Okay, so you can talk about that either with transformations or measurements. So if you're talking about transformations, you're going to be talking about rigid motions. So, and that's the activity that we hope that you guys just did, the cut it out activity. Rigid motions are one of the three things down here: a flip, a slide, or a turn. You can show that two shapes are the same or congruent if you can take rigid motions like a flip, like if you can take one figure, flip it onto another, and they match up completely, angles and sides, they're called congruent. So that's what that whole activity was focused on, was transformations. But the notes today, we're going to focus on measure. So two figures are congruent if their corresponding parts have the same measures or same measure. So by that, I mean we got to match up sides and match up angles. Okay, so there's an example down there of two shapes. They're four-sided quadrilaterals. Believe it or not, they're actually congruent. You could flip, turn, slide them around, and they'd lay right on top of each other. But what we're going to be talking about today is how do we write, precise statements about that, and how can we use that to answer questions. We measure with protractors and with a ruler, as you can see down here. So let's see the idea in action. So up here, this is called a congruence statement, and it's got a lot of information. It's not just naming the shapes. It's telling you what's equal to what if you pay close attention. So we see in this nice figure down here, they look congruent, right? You could probably flip one onto the other. But the colors here mean something. So it looks like it's telling me that A and E are the same, B and F, C and G, and D and H. But those are vertices, right? Those are points. We care about the angles, right? So angle A is congruent to angle E. Angle B is congruent to angle F, and so on. So we just wrote down all the congruent angles. Done. That's it. What I want you to focus on, though, is that A goes with E, and the second one, B, goes with F, and so on. So the order, they're telling you which angles go together. Okay? So really useful to have that. Okay? Corresponding sides are actually the same thing. You just go in order. So, for example, the first two letters on the first one should be equal to the first two letters on the second one. What I mean is this and this, those sides should be the same in length. So remember, we call those congruent sides. So what that means on the picture is that this length is equal to that length. Okay? So BC is congruent. BC is congruent to what? How about FG? It's all about just going in order. So these two are equal in length. The segments are congruent. Okay, and there's two more, right? CD should be congruent to GH, and D, and then start back over at A, should be congruent to H, start back over. What I mean by start back over, I'm talking about DA should be the same as HE. Okay, so we're talking about sides, and we're also talking about angles. And if all of that matches up, then you have congruent figures. Okay, so that's the new piece of information today from geometry, is corresponding parts mean that the figures are congruent. All right, so let's practice doing this matching game. So they tell me to find x and y, but they give me this very nice congruence statement. So AB, this length right here, I know right off the bat that this is equal to PQ because the order matters. So these two are the same in length. So that means, so AB is equal to PQ. And then just do some algebra and we get 8 is y. Okay? So what about this other length? What about this one? We could call that PR, or we could call it RP. I'll call it RP is equal to, we hope it's this one, but we got to make sure. So R and then P should be C and then A. So third and first, and they match up. So visually, what does that mean? That means that this is 15. Oops, this one's 15, and this one's X. There you go. Corresponding parts on congruent figures are equal in measure. Okay, so it's just a matching game with these types of problems. So here's another one. They give us another congruence statement, and they say find x and y. So again, if we want to learn about AB here, we look and say AB. That goes with DC. DC's right here. And that turns out to give us a very nice equation for x. First two letters going with the first two letters. They're talking about sides. Put them together and you're good. Okay? Now, this is talking about an angle. So this angle and this angle, we can't call that angle, they can't call this one here. You can't call that angle B. Because B it kind of has two angles. It's got this one and this one. So we have to use, remember with angles, sometimes we use 3 letters. And it turns out that the triangles have 3 letters in their name. So what I'm going to do is just go ahead and say, let's start at A. It really, this is a little tricky, but how about angle ACB? So I'm talking about ACB. So it's the 5y. So 5y is the measure of that. And we're hoping this is 73, right? But we want to be precise. We want to practice writing the statements of equality, these congruent statements. So what I'm going to do, and this works. How about A and D go together? So A should go with D, and then, right? So do you see what I just did? I am taking each letter here. So this next one, C, that corresponds with B. Because C is the last letter. Like the last letters go together. Like those points correspond. And B where does B go? So if it's B, if it's this B, it should correspond with this C. So that's it. You know, it's almost like you're subbing in these letters for the congruent statement. Like, you know, the first one's equal to the first one, the second's equal to the second, and so on. Because we can't just assume that these are equal. We have to write a statement using the congruence statement that was given. Okay, but in any case, it looks like this will be equal to a fraction there. Okay, what about this one? So I think there's a typo. Sorry guys, this is measure of angle W. Right. So this figure, let's see, let's label what's given. This is 83 degrees, and this is 64 degrees. Now, these triangles, it's very clear like which angles correspond. For example, W corresponds to angle B. So shouldn't this one be 64? And kind of just got us the answer really fast. But hey, I mean that's it. You know, that real small angle there, angle W, corresponds with the small angle on the other triangle. And we see that because it didn't come first. Okay? So that one's a bit quick. What about here, Ozzy? Ozzy says that since angle N, which is down here, is congruent to angle Q, and angle O is with R. That's what these lines mean, right? So Ozzy says because that picture is there, that means that angle S must correspond to angle P. And we want to know if that's right or wrong. But I think he's right, guys, because so even though this is a little sloppy, I'm going to still write this just to save some time and clear up the notation a little bit. If we add up we're going to pretend like these are angles I'm adding up. This should be 180, right, guys? I should be using like measure of angle N is, you know, rather than using N, but let's just relax that for a second. It's actually a really cool thing we can do here. If we subtract these equations, knowing that this one is the same as N and the R is the same as O. Remember you like subtract equations when you're doing like elimination a long time ago in algebra? This is 0, 0, P minus S equals 0. Doesn't that mean that P is S? Think about it. That is true. That's one way to show that Ozzy's right. But we can remember it more simply as the third angle theorem, meaning that if you have a triangle and two of the angles are congruent, the third one is also congruent as well. Very, very useful. We will use this in proofs. We'll just have like 1 or 2 proofs on the test. It's not going to be like the last one where it's like mostly proofs. But that's that. So let's look at this one really fast. It wants to know, are the triangles congruent? And if they are, you have to write a congruent statement. So what we just learned is that if we have O and N matching and these two angles matching, that the third angles, they match as well. We just learned that with the third angle theorem. Okay. And so it looks like all three angles are matched up. Right? All three angles match up. And then this long side here that they both share, they both share it, right? ln is congruent to ln. So we're going to do a proof here, and that's the reflexive argument, is that ln is equal to ln. And the reason why we write it is because both triangles have ln. But it's not necessarily clear that they're equal, so we have to make the statement that says, hey, those two things belonging to two separate triangles, they're actually the same because they just overlap each other. So we can say that, let's write the congruent statement then, because it looks like all of the three sides, all of the three angles are there. So to write the congruent statement, I would look at the angles and say O and M are the first angle because they have one arc. L looks like it's the next one, right? So O to L and M to L. And then the last angle is N over there. So how about this? Does this make sense? It matters the order. It really does. Because you got to make sure that the arcs of the angles go together. Like, for example, this one. The one arc has to match. They have to be in the right order. Okay. Again, I said earlier, this is all about ordering. What could you say about this angle here and this angle? Are they the same? Yeah, those are equal. Equal angles by vertical angles, right? Maybe vertical angles theorem. Okay. And hey, that means we have 1, 2 angles. It also means that these are equal by the third angles theorem. Remember, if you know 2, you know 3. Okay. But they didn't give us anything about the sides, right? So couldn't we have a picture that looks like this? Or a picture that looks like this? Like, we're not given anything that nails down this triangle. No information about sides. So the answer here is just no. They're not congruent triangles. They look like it, but there's no restrictions on the sides, and they could really be anything. The angles match up, though. We call those similar. The angles match up. Okay. So I have some proofs for us to do, and then that'll be it for the video. So it's more important about just listening to the process. So when we're given 4 different things, so let's label everything. AB is parallel to DC, and we have some congruent sides as well. AB is congruent to DC, and even BC, I'll use 2 marks, and AD. And we also have that B as an angle is the same as D as an angle. And we want to prove that we have a congruence statement. Okay, so all that junk is given. So rather than, I'm going to redraw this picture so we can show like our progression of like the order that we add things on, and we can look back on it. So I'm going to copy down the picture. Okay, because we won't be giving you a blank proof on the test, but I want to show my process as much as I can. Remember, we have to match up the 3 angles and the 3 sides. We're really close on the sides, though. We only need the third one. So the third side is this one. That one hasn't been marked yet. But we know that they're the same. They're the same. So I'm going to write AC is congruent to AC because it's reflexive. Okay. I know the word reflexive because in Spanish we have reflexive verbs, right? If you're in Spanish, that means that they refer to themselves. So that word reflect, that's where I recognize that from. So reflexive, you think of referring to itself. So we have AC and AC. That was a tangent. But, so the sides are great. We're all good on the sides, but the angles, not so much. So we made that recognition first. And then how about we have some parallels? So couldn't we say something about some of these angles? What about this angle? Which one does that match up with? We got a parallel line with a transversal. We got this one. Those two should match up. Right, so how do we say that? How do we say that in a nice way? How about angle DCA is congruent to angle BAC? Okay, and this is, I mean, it's really tedious. Just try your best to label those angles. Don't worry too much about labeling them in order. But those two angles are equal. Why? Because they are alternate interior angles. We have parallel lines, so we should always expect to use those angle pairs. But, so this next step though, hey, we have 2 out of the 3 angles matching up. So what's really great is that we can just right away say that these match up too. And that's because of the third angle theorem. So how do we label them? We can't just label it as C and A because that's not specific enough. So how about angle ACB? So this one is congruent to CAD. So the writing and the labeling is really monotonous and difficult, but the idea was that we got the third side here, the second angle here, and the third angle pair there. So we do have everything matching up now, so we can say what we were looking to prove. So the reason for this, you could say a number of things, but I would say that the corresponding parts match. Okay, so all 3 angles and all 3 sides. All right. Okay, that's that. So pay more attention here. I'm more concerned about getting that picture down. Okay. And then this last one here. So angle A and D match up. AB and DE match up. And, oh, here we go. We got bisect going on. So that's the first thing that will probably boil down in our proof is what does bisect mean and what can we draw because of that. Yeah, what does it mean that so this length and this length, they bisect each other? Well, what it means is that these two parts here, these and these, they're equal. They get cut in half, or that's what bisect means. So I'm going to go ahead and write that BC is congruent to CE and AC is congruent to CD. But what I want you to see is that these two match and these two match. So this is the definition of bisect. I'm fine with that. Okay, so that's a real big hurdle of a step, but it's really nice because now all of our sides correspond. So now we have to focus on the two missing angles. A and D are accounted for, but the other ones aren't. We have no parallel lines, so we can't rely on that. But what do you guys think about this right here? What about those two angles? I think they're vertical, right? So vertical angles are congruent. So how do you want to label them? Well, I'm not a huge stickler when we're doing two-column proofs about using the right order, but how about ACB is congruent to DCE? So that would be very correct, because we go along the 3 hash marks and then we go along the 2 hash marks. So we should be doing the same with the other triangle in the order. That's kind of advanced, but we'll get there. So that third angle though should be the same too. This one. So third angle theorem. Okay. So angle CBA is congruent to angle CED. Those blue ones are equal. Okay, so we've matched all 3 up, so we get A, C, B. We get what we want to prove. So why is this true? The same reason as before. The corresponding parts are congruent. So we're going to use the word corresponding and congruent a ton. So corresponding just means that you have this matching. Like we know, like this is a matching. We know the angles match. But in math, when we say match, we mean that they're congruent. All right, so you've got some practice problems. Just try one of those proofs. I would try both of them, but give that your best shot, and we're here if you have any questions.